Welcome back, my dear students. Today let us solve some of the problems on the basic properties of fluid. So whatever we discussed, the specific weight, density, specific gravity, okay, n number of things what we studied in our last classes. So to understand them better, we will apply or we will calculate some of the problems. Okay, so see here the first question: calculate the specific weight, mass density and specific gravity of 1 liter of a liquid which weighs 7 Newton. Okay, so I am doing this lecturing on the channel Civil Knowledge, so please subscribe if you are not yet subscribed. Okay, I am completing this fluid mechanics syllabus full in this channel for this semester. Thank you. Okay, so let us go to the problem. So we have to calculate the specific weight. Okay, specific weight, what is the notation? Specific weight. Okay, we have to calculate specific weight, mass density, fine, and also the specific gravity. So specific gravity notation is yes. Okay, so what are the data given? Which data we are having? So we are having what? They are given as 1 liter of liquid. So 1 liter means what? It is nothing but our volume. Volume is given as 1 liter. So as this is first problem, I'll go very slow and in detail. So in coming problems we will go on by using the notations. Okay, so volume is 1 liter and what is given? Weighs 7 Newton. So weight is given, it is 7 Newton. Fine. So okay, now volume is given in liter, so we have to convert it in meter cube per second. Why? Because of the SI unit system. So 1 liter is there, so how to convert? So your 1 liter is nothing but 1 by 1000 meter cube, or we can also write 10 to the power of minus 3 meter cube. If this 0 goes up, we will get as minus 3 meter cube. Okay, now so I'll consider this. So the volume will become as 1 into 10 power minus 3 meter cube, and we also know the weight. The weight is, so capital W, the weight is 7 Newton. So what we have to find? We have to find what? Specific weight. So according to the definition of specific weight, what is the definition? So specific weight is equal to weight per unit volume, weight by volume. So what is weight? Weight is given as 7 Newton. So what is volume? It is 1 into 10 power minus 3 meter cube. So when we solve, we will get as 7, 10 power 3 will go upward and will become 10 to the power of 3. 10 power of 3 Newton per meter cube, or we can also write as 7000 Newton per meter cube. Correct, just we have to substitute the formula. Next, what they have asked? They have asked for density. So next, mass density or density is equal to, what is the notation? This one. So we have a relations between this specific weight, what is that? Density into gravity. Remember this. Okay, specific weight is equal to mass density into G is acceleration due to gravity. So what I want? I want density. So I know this specific weight by G. So I'll take specific weight divided by, and G, it is universal, that is 9.81 meter per second. So now density, what is weight? It is 7 Newton, right? So what is weight? 7,000. So before converting, I'll write down 7 Newton, and it is what? 9.81 meter per second. Sorry, see. So density is 7 Newton divided by 9.81 meter per second. Correct. So but our density's unit is what? Kg per meter cube. So I'll convert this 7 Newton into what? Kg. Okay. So it 7 Newton is nothing but 7,000 divided by 9.81 kg per meter cube. Okay, if we simplify, we will get 7,000 divided by 9.81, it is 713.55 kg per meter cube. So next, what we have to find? We have to find this specific gravity. So specific gravity. So according to definition, what is that? We have to take weight of liquid to the weight of standard liquid. In the case of liquid, it is what? Water, right? So here it is 7 Newton I have taken. So what we got? The specific weight. Weight is nothing but 7,000 Newton per meter cube. Okay. So it is, sorry, 7,000 Newton per meter cube. Next, specific gravity is what? Weight of standard liquid to weight of the weight density of the liquid to weight density of the standard liquid. So what is the weight density here? We have got that is 7,000 Newton per meter cube. So 7,000 Newton per meter cube. So 7,000 Newton per meter cube. So I already told you what is the weight density of water. It is nothing but 1000. It is what? Density of water into 9.81, or you could directly take that is 7,000 divided by 9810 Newton per meter cube. Then the specific gravity we are getting as 0.7135, which is a dimensionless quantity. Okay. So density ಕೇಳಿದ್ರು, specific weight by gravity. Specific gravity ಕೇಳಿದ್ರು. Specific gravity ಬೇರೆ, acceleration due to gravity, they are both are different. Okay. Now you can also find the density in another way. I'll show you here. So according to definition, what is density? Density is equal to mass by volume, right? So do we have mass here? So mass is not given, it is given in terms of Newton. So remember here 1 kg is equal to, okay, 9.81 Newton. So 1 kg is equal to 9.81 Newton. What we have? We have 7 Newton. So how many kg? So it is nothing but 7 divided by 9.81. So we will get around 0.71355 kg, right? Now I'll take the mass. So it is what? Mass is what? Dependent on what? Gravity. Okay, some gravity factor it comes into picture. So what is mass? It is nothing but 0.1 71355, this one. So this is what? Mass divided by what is the volume? Volume is, you know, that is 10 power minus 3, correct? Now if we solve this, that is 0.71355 divided by 10 power minus 3, you will get what? 713.55. 713.55 kg per meter cube. This is what? Density of the liquid. So I was going to make this, so and I made a mistake here. Okay, take one formula at a time so that you will not have any confusion. So I'll go to the next problem. So I hope you understood this problem. Okay, so next one, I have already written the question to save the time. So here, calculate specific weight. So we'll go now somewhat speed. Okay, calculate specific weight. So okay, what is the given data? I will write first. Calculate weight, volume and specific gravity of a liquid having volume of 4 meter cube and weight of liquid is 29.43 kilonewton. So given volume is given, same as earlier problem, only 4 meter cube directly they have given, and also the weight of liquid 29.43. so kilonewton it is given, it is not newton, it is kilonewton. So now I'll convert it. So 29.43 into 10 power 3 newton. Okay, so volume is 4 meter cube. So with the knowledge of the formula, so what we know? We know that the specific weight is equal to what is the weight of the fluid to the volume of the fluid, correct? So weight by volume. So what is weight? 29.43. So 29.43 into 10 power 3 divided by volume is 4 meter cube. So when you substitute, you will get, so 29.43 into 10 power 3 divided by 4, it is 7357.5. 7357.5. So what is the unit of specific weight? It is nothing but Newton per meter cube. Okay, this was about specific weight. Then what they have asked? They have asked specific volume and also gravity. Okay, so I'll write down here. So weight is asked, specific volume is asked, specific gravity is asked. So now what is specific volume? See here, before finding specific volume, okay, I'll find the density. Okay, so we know this relation, that is specific weight is equal to mass density into gravity. So by this I can find the mass density, or I can use this mass density is equal to mass by volume by converting the terms. So both you will get the same answer. So I know weight. Okay, now what I need density. So density is equal to specific weight by gravity. So what is specific weight? 7357.5 Newton per meter cube divided by gravity is 9.81. So if I divide that by 9.81, I am getting your density as 750, okay, kg per meter cube. This is the value of density. So once I get the density, I can find the specific volume very easy. So what is the specific volume? It is nothing but the reciprocal of this density. So specific volume is what? It is the reciprocal of density. So 1 divided by 750 kg per meter cube. So if I solve this, I'll get as the specific volume is equal to 1.334 into 10 power minus 3. So it is ulta, meter cube per kg. Okay, see here. Then what we need to find? We need to find specific weight, volume, and remaining is specific gravity. So finding specific gravity is very easy. What is that? So specific gravity, yes, is equal to, either you take weight density or weight, any one item you take. If you take weight density of the fluid, you have to take weight density of the water, standard fluid. If you take density of the fluid, then you have to take density of the standard fluid. Whatever you take one uniform volume value. Okay, both reciprocal and the numerator and denominator should be of the same type. Now I'll take now weight only. So specific weight of this liquid divided by specific weight of standard liquid. So specific gravity is equal to, what is weight we have got? It is 7357.5. So 7357.5 divided by 9810. So I already done here how that 9810 is. 1000 into 9.18, 9810. So once I substitute that 7357.5 divided by 9810, I'll get your specific gravity as 0.75, and it is what? Dimensionless quantity. So dimensions are very important here in this subject. Now let us write a note. Okay. So what is that note? So whenever in the problem, when you encounter with the mass density of water, whenever come with the term mass density of water, it is 1000 kg per meter cube. If the same is termed as weight density of water, then it is what? 9810 kg per meter cube. Okay, and also conversions are very important. Okay, when you practice you will be perfect. It is what? 1 Newton. Okay, 1 Newton is equal to what? Point, you will get in point terms. Okay, 0.1019 kg, or you can use 1 kg is equal to 9.81 Newton. We are familiar with this. And also 1 liter is equal to 1 by 1000 meter cube when it is in meter, or it is 1000 cm cube, cubic meter. Okay, remember this 1000 cubic meter is nothing but 1 liter. So remember this. We will go to our next problem. So your third problem, if a liquid has a mass density of 1265 kg per meter cube. See here, directly you have given with the mass density as 1265 kg per meter cube, or hengara kodli, just be sure that what is given. Okay, 1265 kg per meter cube. What are the what are the values of its specific weight, specific gravity, and specific volume? So by giving the value of density, he has asked to find specific weight, specific gravity, and specific volume. Now, so we already know when density is given, what is the formula for specific weight? So solution, so specific weight and density relation is specific weight is equal to density into gravity. So with this formula, what I can write, specific weight is equal to 1265 into 9.81. So my specific weight will be 65 into 9 point, so 12409 12409.65. what is the unit? Newton per meter cube. So this is our specific weight. Next, specific gravity. So before specific gravity, we'll find the specific volume. So what is the specific volume? So specific volume is nothing but the reciprocal of density. Just divide it by 1. You will get the specific volume. That is, specific volume is equal to 7.905 into 10 power minus 4 meter cube per kg. Simple problem will be given, just to make you practice about the formulas. Then what is given? Specific volume is found out. Now specific gravity. So density. So in this problem we will calculate by density. What I will do, density of this liquid given to the standard liquid. So standard liquid is what? Water. So what is the density of the given liquid? That is 1265. So 1265. So then density of water is what? 1000. So when I multiply, what I will get? Specific gravity is 1.265, and it is dimensionless quantity. 1.265 is the specific gravity. Easy, right? Now next I will go to another problem. I already copied the question. So a 5 liter of oil weighs 61.81 Newton. So a 5 liter. So volume is given, weight is given. Calculate specific weight, specific volume, specific gravity. So I'll try to solve directly. So volume, it is 5 liters and weight is 61.81 Newton. This is the given value. We have to find with the same formula and with the same notation. So as in the note, what I discussed, so volume will be 5 into 10 power minus 3 meter cube. So weight, let it be in Newton only. Then specific weight, so weight by volume of the fluid. What is weight? 61.81. What is volume? 5 into 10 power minus 3. So what we will get if I divide 61.81 divided by 5 into 10 power minus 3. So it is 12362. So what is the unit? Newton per meter cube. Specific weight I found out. Then what I need? I need specific volume. So same, specific weight is equal to density into gravity. So now density is equal to what? This 12362 divided by 9.81. So it will be 1260.14 kg per meter cube is your density. then volume will be what? Specific volume, reciprocal of that 7.93 10 power minus 4 meter cube per kg. So specific volume is also found out. Then what? Specific gravity. So we already know weight. What is that? 12362 divided by 9810. 12362 divided by 9810 is 1.26. 1.26 is your specific gravity. Okay friends, I think you understood these 4 problems which I had explained now. We'll go to next topic. So before going to the next type of problems, I'll refresh some of the formulas which we have learnt in the PPTs. Okay, so what is that? So note number 2. So we have learnt some of the formulas under Newton's laws of viscosity heading, that is shear stress. Okay, shear stress tau is equal to mu into du by dy. Okay, shear stress tau is equal to u into du by dy, that is, this is tau is nothing but your shear stress, u is nothing but the what? Your coefficient of अथवा constant of proportionality अथवा coefficient of dynamic viscosity. So coefficient of dynamic viscosity. So viscosity andrenu resistance to flow, viscosity. So this du by dy, what is this? It is nothing but the change in velocity. Okay, change in velocity, or it is also called as velocity gradient. Okay, so the difference in velocity per unit distance between two layers is called as velocity gradient. So tau is equal to mu into du by dy. It is one of the formula. Then now some of the conversion. So because while doing problem you should not be confused, so I am noting this down before only. Okay, so what is the conversion? So in the problem you may get as 1 poise, POISC. So this 1 poise is nothing but 1 by 10 Newton second per meter square. So I have discussed in the PPT, but for remembrance I am writing it again. So 1 poise is equal to 1 by 10 Newton second per meter square, and 1 stroke is equal to what? 10 power minus 4 meter square plus second. Okay, so either this you need to, so I'll tell another formula for you. You will have another term like kinematic viscosity. So kinematic viscosity. So in some textbook it is referred as small v, and in some textbook it is written as eta. Okay, now so what is the formula? It is nothing but the dynamic viscosity divided by mass density. Okay, so it is not or. Okay, so it will confuse, let it be. So I'll take only one term, either this or this. So kinematic viscosity is equal to what? Your dynamic viscosity mu, which you taken here, mu, coefficient of dynamic viscosity, divided by density. Remember this. Okay. So this unit may be in terms of Stokes. Okay. So what is the unit of this? Centimeter square per second in CGS system. Okay. Next, or meter square per second in SI system. So meter square per second. So right now this is enough. So for SI unit it is meter square per second in CGS. So this is not so important to us. So remember, meter square per second only. Okay. So I'll go to one of the problem now. I'll copy the problem for you. So the problem number is 5th one. See here, my dear students. If the velocity distribution over a plate is given by u is equal to 2 by 3y minus y square, where u is the velocity in meter per second at a distance of y meter above the plate, determine the shear stress at y is equal to 0 and y is equal to 0.15. Take the mu, what is dynamic viscosity, as 8.63 poison theory put it there. So this is the given data. So now what we have to do, we have to find the solution. That is, we have to find what? We have to find the shear stress at y equal to 0 and y equal to 0.15. Here the velocity is given in terms of what? In terms of an equation. Okay, equation kotar ant heli tele kadiskonadu beda. Now whatever it is given, we will take that. So they have given that mu is equal to what? 8.63 points, right? So what note I have given to you, that is whatever is given in points, you have to convert in Newton second per meter square, that is 1 by 10 Newton second per meter square. So what it will happen? So this mu is equal to 1 by 10 alwa, 8.63 by 10 Newton second per meter square. So your mu value will be 0.863 Newton second per meter square. Next, what we have to do? We have to note down this function. Okay, function of y, velocity is given in a function. So u is equal to 2 by 3 into y minus y square. So we have to differentiate. Yadaki differentiate madabeku. So we have formula, that is namagu gottiro formula enu, tau is equal to enu, your dynamic viscosity into du by dy. So what we want? We want this velocity gradient. So differentiate with respect to y. So differentiation of u we will get with respect to y. What we will get? So differentiation of 2 by 3y is 2 by 3 only, minus differentiation of y square is what? 2y. So du by dy ಏನಾಗುತ್ತೆ? 2 by 3 minus 2y. Take this as equation number 1. Okay, remember this. I will go to the next page. Okay, or else I can find here only. See here. So what we have to find? We have to find that y is equal to 0 and y is equal to 0.15. Now namagen values beku du by dy, y is equal to 0 ಇದ್ದಾಗ ಎಷ್ಟು, du by dy, y is equal to 0.15 ಇದ್ದಾಗ ಎಷ್ಟು ಅಂತ ಬೇಕು. ಯಾಕೆ ನಮಗೆ ಟೌ 0 ಇದ್ದಾಗ ಎಷ್ಟು, ಟೌ 0.15 ಇದ್ದಾಗ ಎಷ್ಟು ಅಂತ ನಾವು ಕಂಡುಹಿಡಿಬೇಕಲ್ಲ. ಸೊ ಅದಕ್ಕೋಸ್ಕರ ನಾವು ಫಸ್ಟ್ ಏನು ಮಾಡಬೇಕು? ಸೊ du by dy, ಸೊ at y is equal to 0, du by dy is equal to, so 2 by 3. So y ಏನಾಗುತ್ತೆ? So this term will be 0, right? So 2 by 3 minus 0, it will be 2 by 3. So if we simplify more, it will be 0.66. Next, at y is equal to 0.15, du by dy is equal to 2 by 3 minus, so 2 into 0.15 is 0.3, so it will fetch us this 0.66 minus 0.3, that is nothing but 0.36 meter. Okay, so du by dy value at y is equal to 0 is 0.66, du by dy value at 0.15 is 0.36 meter. So now what we need shear stress at 0. We need to find shear stress at y equal to 0, shear stress at 0.15. So we'll do in the next page. That is nothing but, so tau naught, so tau is equal to mu into du by dy at y is equal to 0. So tau naught is equal to, what is the value? 0.863, right? So 0.863 into du by dy. So value of du by dy is 0.66. It implies tau naught is equal to 0.863, 0.66. So here units are very important. Okay, conversion is very important. So here you may think it is easy, but while doing you will face the actual problems. If I didn't convert, it will be what? 8.63 into 0.66, so 5.69. So like this it will be. So conversion is very important. 0.569. So what is the unit of the shear stress? So shear stress is what? Newton per meter square. Similarly, what we have to find? We have to find shear stress at y is equal to 0.15. So mu is 0.863. So du by dy is what? 0.36. I think so. Let us check. See here, 0.66 and 0.36. So let me align the camera. Okay. So 0.36, which implies tau at 0.15 is equal to, so 0.863 into 0.36, it is 0.310 Newton per meter square. So shear stress at y equal to 0, 0.569, shear stress at 0.15 is 0.310 Newton per meter square. So this is the solution of this problem. Next we will go to another problem. So your next problem is sixth one. So the plate at a distance of 0.0254 mm from a fixed plate move at a velocity of 0.61 meter per second and requires a force of 1.962 Newton per meter square. So determine the dynamic viscosity of liquid assuming the linear velocity distribution. Okay, so the plate is at a distance of 0.0254 mm from a fixed plate. Two plates are there, so one is moving and one is fixed, and which is moving, it is moving with a velocity of 0.61 meter per second. Okay, and it requires a force of, if requires a force means, in this case the force means what force? It is nothing but the shear stress. Okay, 1.962 Newton per meter square. So determine the dynamic viscosity. What we have to find? We have to find mu. Okay, assuming the linear velocity distribution. Fine. So what they have given? So distance is given. So distance we will calculate by y is equal to 0.0254 it is mm. So millimeter they have given. I'll convert into meter. 10 power minus 3 meter. So y is given. Next, velocity, initial velocity is given. Okay, that is 0.61 meter per second. Then what is given? Force of, okay, which force is acting? It is understood that it is nothing but the shear force, that is tau, that is what? 1.962 Newton per meter square. So determine the dynamic viscosity we need to find this one. So it is a direct question. So tau is equal to what? Mu into du by dy. Correct? Now what we need to find? We need to find this mu. But here only one plate is in this picture. So what we will take? We will not take the change. We will directly take what? Tau is equal to mu into u by y. Okay, so in context with the two plates only we are talking. So one is fixed and another one plate fixed adag ಇನ್ನೊಂದು plate move ಆಗಬೇಕಾ. So ಅದು ಒಂದೇ ಸಿಂಗುಲರ್ ಇರೋದ್ರಿಂದ ಡಿಫರೆನ್ಸ್ ಬಿಟ್ವೀನ್ ದೆಮ್ ಬರೋದಿಲ್ಲ, ಯಾಕಂದ್ರೆ ಒಂದೇ ಯೂನಿಟ್ ಇರೋದು. ಸೊ ಯು ವಿಲ್ ಟೇಕ್ u by y. So it is distance, it is initial velocity. So for this thinking they have given this, they have framed this question. So what is now we have to find? So tau they have given 1.962 is equal to mu. We need to find u is to 0.61 divided by y is 0.0254 into 10 power minus 3. What we need? We need this mu is equal to, so 1.962 into 0.0254 10 power minus 3 divided by, so 0.61. Once I simplify that, I'll get as, so 1.962 0.0254 into 10 power minus 3, so divided by 0.61 meter per second. It is nothing but 8.169 10 power minus 5. What is the unit? Newton second per meter square. You can convert it into poise and also you can write poise al convert ಮಾಡಿ ಕೂಡ ನೀವು ಆನ್ಸರ್ ಇಡಬಹುದು. Okay, for this answer, for this question, the solution is that mu is equal to 8.169 into 10 power 5 Newton second per meter square. Okay, now let us go to another problem, the last problem of today's session. Okay, so next problem is 7th one. So important question. Okay, so the topic is moreover assumption is there here. Okay, please concentrate. So if the velocity profile of a fluid, okay, they are directly giving the, they are not telling the equation, they are giving the profile. So if the velocity profile of a fluid over a plate is parabolic, so the velocity profile is parabolic with the vertex 20 centimeter, okay, with the vertex 20 centimeter from the plate where the velocity is 120 centimeter per second. Calculate velocity gradient and shear stress at a distance of 0.10 and 20 centimeter from the plate if the velocity of the fluid is 8.5 poise. So here one value is 8.5 poise they have given. Okay, and in this problem ಅವರು ಡೈರೆಕ್ಟ್ ಆಗಿ ಏನು ಕೊಟ್ಟಿಲ್ಲ ನಮಗೆ. So they have just informed us that there is a velocity profile and also the parabolic. Okay, so now it is our duty to interpret correctly. Okay, so I'll write first what is given. The given data is, I'll write. So what is given? See here, 20 centimeter from the plate. So what is that? It is nothing but the distance of vertex. Vertex means point from plate. So at from a point, the distance of the plate is what? 20 centimeter. And they are also given that velocity of the vertex. So velocity is given, that is 120 centimeter per second. Then with the viscosity of the fluid, so they have also given the viscosity. So viscosity of fluid, so what is that? 8.5 poise. Okay, so I'll convert here only 8.5 ಇದೆ ಏನಾಗುತ್ತೆ in Newton second per meter square. So 1 poise is equal to 1 by 10 Newton second per meter square. So it will be what? 0.85 Newton second per meter square. So I'm going to this time. So now what we have to do? We have to, as they told that there is a parabolic and also the velocity profile. So the velocity profile is given parabolic, and equation of velocity profile is, before that I'll write a graph for you to easily understand. So I'll take this as velocity and it is distance. Okay, so this is 0 point, right? So the velocity profile, how is that? It is parabolic. So how is the parabola? So this is the parabola. Means what? Initially 0 irutte, ಮೇಲ್ಗಡೆ ಹೋದಾಗೆ as the value of y and u increases, it will give the shape of parabola. Okay, so ಇಲ್ಲಿ 0. So ಇಲ್ಲಿ value ಕೊಟ್ಟಿದ್ದಾರೆ, ಏನಂತ ಕೊಟ್ಟಿದ್ದಾರೆ? So when u is 0, y have something value, y is also 0. When u is 20 centimeter, when the velocity is, see here, with the vertex 20 centimeter, when the distance of the vertex from the plate 20 centimeter iddaga, the velocity is what? 120 centimeter. So here u is equal to, when it is 20 centimeter, u is what? 120 centimeter per second. Okay, so this is the thing which we have to interpret from the given question. So they directly given the, it is parabolic variation. Okay, so at 20 centimeter the velocity is 120 centimeter per second. Then what we have to do? So we must know what the equation of parabola. What is this? Parabola is parabola. So equation of parabola, what is this equation? So we have to remember, anywhere in any problem, if they give the parabolic variation, we have to remember only one of the equation, that is with respect to the velocity profile. Okay, equation of parabola with respect to the velocity profile is u is equal to, if you know this, you can solve this problem. If you can't interpret this only, you can't solve this problem, it will be difficult. Okay, so the velocity profile is parabola. So parabolic equation for the velocity profile is u is equal to, so ay square plus by plus c, ax square plus bx plus c. We have already know this, but in place of x, it is, we have taken distance as y, right? So ay square plus by plus c. So this is the equations of parabola. I'll take this equation as 1. Okay, whenever the velocity will come, I'll take this equation. So what I do, I'll differentiate it. So I'll differentiate with respect to y. Equation 1 is differentiated with respect to y. So what I'll get? So du by dy, I'll get the velocity gradient or change in velocity. What will be that? A into y square. What will happen? Differentiation of y square is what? 2y, so 2a into y plus differentiation of by is b plus c will be constant, it will be 0. Differentiation of c is 0. So this is the another equation, du by dy is equal to 2ay by y plus b. So this is the equation number 2. So I will get equation 1 and equation 2. Now I will use what? The boundary condition. So what are the boundary condition respect to this problem I will use now. So what are the boundary condition? We have 3 boundary condition here. See what? At y equal to 0, when y equal to, when distance is equal to 0, when u is equal to 0, what is the performance of this velocity or this gradient? Okay, how the equation will be compatible. Next, when y is equal to 20 centimeter, so here you see when y is equal to 20 centimeter, u is what? 120 centimeter per second. So what will be the condition if we substitute this? Okay, and also at y is equal to 20 centimeter, what will be change in the du by dy? What will be the change in the velocity gradient or in change in velocity? So these are the 3 boundary conditions which I am going to apply here. So I'll apply the first boundary condition, that is at u is equal to 0 and also y is equal to 0 in equation number 1. Whenever I tell equation number 1, what is that? U is equal to ay square plus by plus c. U ಜಾಗದಲ್ಲಿ 0 ಹಾಕಿ, y ಜಾಗದಲ್ಲಿ 0 ಹಾಕಿ. What will happen to that equation? So u is what? 0 is equal to a, y is what? 0. So this is also 0. I will write the equation. Wait. U is equal to ay square plus by plus c. So when u is equal to 0, it will be 0. So it will also be 0. It will also be 0. So c is constant. So when with the first boundary conditions, I am getting the value of c as 0. Okay, in this equation ಇದು ಬಂತಂದ್ರೆ ಏನು ಕಂಡುಹಿಡಿತಿದ್ವಿ ನಾವು? a b c we need to find, right? So now I got the value of c. Now I will apply second boundary condition, that is at u is equal to 120 centimeter per second, and at that what is the value of y? It is 20 centimeter. So both are in centimeter, no need of conversion in equation number 1. So take the same equation number 1. So when u is 120 centimeter per second, so u is equal to ay square plus by plus c, which implies, okay, your 120 is equal to a into what is that? 20 square y value plus b into 20 plus c. But c value what we got? As 0. So the equation will be what? 120 is equal to 20 square is 400a plus 20b. So we get another equation when we apply the second boundary condition. So I'll call this equation number as 3. Okay, I'll go to the next page. So in the next page what I do? I'll apply the boundary condition third one, that is y is equal to 20 centimeter and du by dy is equal to how much? So third boundary condition is what? So at du by dy is equal to 0 and y is equal to 20 centimeter. So du by dy is 0 and y is 20 centimeter in equation number 2. In equation 1 we can't write, right? In equation 1 we don't have du by dy. So in du by dy, in equation number 2, I'll take this du by dy as 0 and I'll take y as maximum, that is 20. So when I apply that condition, so here I didn't write, so it is 0. Okay. Now, so at y is equal to 20 cm in equation number 2, so I'll write that equation. So du by dy is equal to 2ay plus b. So what we need to substitute in the place of du by dy, what we have to do? 0 is equal to 2 into a into, what is the value of y? It is 20 centimeter plus b. So now what we will get? 20 into 2 is 40a plus b, which is equal to 0. So this is what? Equation number 4. So equation number 4 is this. So I'll write the equation number 3 also. What is that equation number 3? That is 120 is equal to 400a plus 20b. So this is what we got. This is what equation number 3 in the last page. So now what I want the value of a and b. So what I do? From equation 3 and 4, what I'll do? So what is the equation 3? 120, 400a plus 20b. So 4 equation is 0 is equal to 40a plus b. Okay, wait. Now, so 0 is equal to what? 40a plus b. So from this I can convert this b in terms of a, right? So b is equal to what? Minus 40a. Correct? Now, this I'll substitute in equation number 3. That is 120 is equal to 400a plus 20b. So 400a plus 20 into minus 40a. So 400a minus 800a, which is equal to 120. So this will be 400a is equal to 120, which implies the value of a will be 120 by 400. Correct? 120 by 400 is 0.3. So the value of a is 0.3, but it is negative. So when I substitute this a is equal to minus 0.3 in this equation, so 0 is equal to 40a plus b. Okay, in this equation I'll substitute the value of a. 0 is equal to 40 into 0.3 plus b. So 0 is equal to, so 40 into 0.3 is nothing but 12 plus b. So the value of b will be minus 12. So a is equal to, oh sorry, what I did is, I did see the camera, sorry. So a is equal to minus 0.3. So this a I'll substitute in this. 0 is equal to 40a plus b. So 0 is equal to 40a plus b. 0 is equal to 40 into minus 0.3 plus b. So 0 is equal to 4 3 is 12. So 12 plus b. So b is equal to minus 12. So I got the value of a, b, and also c is 0. Now we'll solve the further. So I got, for the parabolic equation, I got the value of a, b and c. Now I can solve the equation as required by the question, right? So what we did, so question is what? we have to calculate velocity gradient. We have to find, that is du by dy, and shear stress at a distance of 0.10 and 20 centimeter from the plate. Okay, we have to find shear stress and also velocity gradient. So first we will find the velocity gradient. So to find the velocity gradient, so velocity gradient. So what is the equation? So what is the equation for velocity gradient? That is du by dy is equal to 2ay plus b. So what it will happen? Du by dy is equal to 2 into value of a is minus 0.3 into y plus b value is minus 12. So du, wait, so this du by dy is equal to minus 0.6 y minus 12. So this is the equation, simplified equation according to the values we got. Okay, so for this value we will find the velocity gradient at y equal to 0, y equal to 10 centimeter and y equal to 20 centimeter. Why we have to find? So they have given calculate velocity gradient at 0.10, 20 centimeter from the plate of the, okay, that's why we are finding. So du by dy, so du by dy, I'll write the equation fully, 0.6 y minus 12, correct. Now so du by dy at 0, okay, so at y is equal to 0, at y is equal to 0 ಏನಾಗುತ್ತೆ? So this will be 0, so du by dy at y equal to 0, correct. So this will be 0.6 into 0 minus 12, okay. Therefore the du by dy will be equal to, so here I did a small mistake. See here, at 0 minus 12 plus b is equal to 0, right? So b akade hodre enagutte, idu also minus b agutte. So minus b minus 12 will be cancels. So b is equal to 12. In a hurry I made a mistake, sorry my dear friends. Okay, b is equal to 12, so the value here become plus only. Okay, that's why I am telling why the answer is going up on the limit. So this is plus 12, this is also plus 12. Okay, so now I'll write in a clear form. See here, at y is equal to 0, du by dy at y is equal to 0 will be 0.6 into 0 plus 12, which implies du by dy is equal to 12. Okay, 12, we don't know the unit here, per second. Okay, meter per second, if they are given in meter like that, centimeter per second it will be. Okay, now so at y is equal to 10 centimeter, du by dy at 10 is equal to 0.6. At the place of y, what we have to put? 10 plus 12, it would be minus 6 plus 12, it will be positive value, that is du by dy at 10 is equal to what? 6 per second. So similarly, at y is equal to 20 centimeter, du by dy 20, what it would be? 0.6 into 20 plus 12, which implies du by dy at 20 what it will be? It will be, so 12 plus 12 minus 12 plus 12, it will be 0 per second. Okay, this is the unit. Okay, so at y equal to 0, it is 12 per second, it is y 6 per second. At y is equal to 20 centimeter, it is 0 per second. Similarly, for stresses, for shear stress, in the same fashion. So what the formula we know? We know only one formula, that is tau is equal to what? Mu into du by dy. So the value of du by dy at y equal to 0, at y equal to 10 and y equal to 20 we already know. Okay, so we'll directly tell you what is the shear stresses at specific points. Okay, so at y is equal to 0, okay, at y equal to 0, so tau is equal to, so mu, the value of mu we already calculated here, see, 0.85 Newton second per meter square. Okay, it is, the value of mu is 0.85. So wait, I'll align. Okay, so tau is equal to 0.85 into du by dy at y equal to 0. What is the value? At y equal to 0, the value of du by dy is 12. So into 12, so that implies tau at 0 is equal to 12 into 0.85. It is 10.2 Newton per meter square. So we got the shear stress. Now at y is equal to 10 centimeter. So tau is equal to 0.85. So what is the value of 10 centimeter? At y 10, what is the value of du by dy? 6 into 6, exactly half of it. So tau is equal to, so 10.2, 5.1. So 5.1 Newton per meter square. If you want, you can calculate 0.5 into 8, 6. So at y is equal to 20 centimeter, what will be the shear stress? It is 0.85. So du by dy is just 0. So 10. At 20, the value of shear stress will be 0 Newton per meter square. Okay, so shear stress is maximum at y equal to 0. As y equal to 20 centimeter, the shear stress is 0 Newton per meter square. So as distance increased, here the shear stress decreased. Okay, keep it in mind. So this was about today's class session. Okay, so if you want, I can revise this once again. So who don't want, they can exit the video. So see here, if the velocity profile of a fluid over a plate is parabolic with the vertex 20 centimeter, okay, from the plate where the velocity is 120 centimeter per second, calculate velocity gradient and shear stress at a distance of 0.10. This may be meter. So some problem is in the question. Okay, they are given like this only. It may be distance of 10 centimeter and 20 centimeter. So that's also I also confused. So shear stress at a distance of 10 centimeter and 20 centimeter from the plate if the viscosity of the fluid is 8.5 poise. So whatever they have given, that is distance of vertex. So distance of vertex means from the initial point, the maximum distance they have given, that is as 20 centimeter. U, velocity is 120 centimeter per second. LE, at a distance of 20 centimeter, the velocity of the plate or velocity of any layer according to the question is 120 centimeter per second. Viscosity of the fluid is given as 8.5 poise. So due to the velocity profile is mentioned here with the parabolic curve, I took directly what? This may be a parabola. I took x-axis as u and this as y. So parabolic curve. So at initial value at y equal to 0, u is also 0. So the parabolic extension, parabolic curve, I'll get a equation, that is this equation already we know. Just we have to implement here. So u is equal to ay square plus by plus c. So what I want also the differentiation of that y. I want velocity gradient to find tau, to find shear stress, that is tau is equal to what? Mu into du by dy. What I need to find here? Shear stress I need to find velocity gradient. So what is velocity gradient? Du by dy. I want du by dy. I differentiate it with respect to y, 2ay plus b. So with the boundary conditions, when y is equal to 0, u is equal to 0, what will be the equation? When y is equal to 20 centimeter, u is equal to 120 centimeter, what is the equation? When y is equal to 20 centimeter and du by dy is 0, what will be the equation? So I applied the boundary condition. When I applied, what is the purpose of applying the boundary condition? To get the value of a, b and c. So when I applied the boundary condition, I got the value of a, b and c. Okay, after simplification, I got the value of a as 0.3, b as plus 12, okay, and c as 0. Here in the simplification, do it properly, I was confused. Okay, a is equal to 0.3, b is equal to 12 and c is equal to 0. So what they tell us to find? Velocity gradient, du by dy. So 2ay plus b. So when I simplify what we got the values, when I substituted the values, I got du by dy is equal to minus 0.6y plus 12. So for this equation, what I need to find? At 0, what is the value? At y is equal to 0, what is the value? At 10, what is the value? At 20, what is the value? What is that? The velocity gradient at 0, how much? It is 12 seconds. At 10 centimeter, it is how much? It is 6 per second. At 20 centimeter, the value of du by dy is 0 per second. Next, when I come to shear stress, with the formula, with the help of this formula, I already find the velocity gradient. I just need to multiply the dynamic viscosity or coefficient of viscosity, that is tau at 0 is 10.2 Newton per meter square, tau at 10 is 5.1 Newton per meter square, tau at 20 centimeter, shear stress at 20 centimeter, it is 0 Newton per meter square. So this was the problem and solution for the question. Okay, so I'll end this session here. So thank you for watching my video and be updated. I'll take some more problems and with some more concepts in our next session. Thank you.